All right, so we are in chapter 26 now, the solar system. So, up to this point, of course, we've talked about the Earth and the different things about the Earth, the weather, the rocks, uh, geological activity on the Earth. But we're also going to try to relate as much of that knowledge that we've gained to the solar system as well, to the other planets in our solar system and how they're similar to the Earth and how they're different from the Earth. And that's in fact the next three chapters. That's basically the lesson that we're going to, or the theme, if you will, that we're going to keep doing is we'll compare what we know, what we know best, the things that are closer to us, to things on the other side of the universe. All right, so let's get started. All right, so these are the different topics that we're going to cover: the formation of the solar system, which happened 4.5 billion years ago. We know that because that's when the Earth formed. That's also when the asteroids formed, and comets, and everything that's in our solar system started then. The sun, of course, is the major player in the solar system. It is the thing that has the most mass. It is what the entire solar system revolves around. It literally is pretty much the center. All right, uh, of our solar system, anyway. As we're going to find out in the next chapter, the sun is just a single star that is in orbit around the center of the Milky Way galaxy, and we'll get more into that later. Then we're going to break the planets into what's called the inner planets and the outer planets. The inner planets are um, um, the rocky worlds like the Earth. The outer planets are also known. So the inner planets are also known as terrestrial planets. The outer planets are known as the Jovian planets, or the gas giants. The Jovian, because they represent they are very similar to Jupiter. Jupiter, of course, being the largest planet in the entire solar system. We'll get into that. Then the formation of the moon, um, uh, the asteroid belt. That's really what they mean right here about the failed. I mean that's actually not a good description of the asteroid belt. I'll talk about that in a little bit more detail. Um, and then yeah. Well, so anyhow, let's get into this. All right. So our solar system consists of, thus far, these are things that we know about. What's called of course, our star, the sun, and then there's a system of 8 planets. There are other objects in the solar system, of course. We'll get into that. Uh, Most of the asteroids exist between the orbit of Mars and Jupiter. That's called the main asteroid belt, and then beyond the orbit of Neptune, there's another region called the Kuiper belt. We'll talk a little bit about that. That's what Pluto is actually part of. What's called the Kuiper belt, and then we come to comets. Comets are basically, a good description of comets are icy, um, dirty snowballs is a good description of them, actually. They sometimes have some dirt associated with them, but they're mostly made of icy material. Water. They're made of frozen water. All right. And now we're going to get into the main division between the planets. Of course, the inner planets, which are also known as the terrestrial worlds, after Earth. Earth, of course, is the largest of the inner planets. This is the order of the planets, of course, you probably learned this at some point. It goes, the closest one, of course, is Mercury, and this is also the closest one. It travels the fastest. All right. And then comes Venus, which, by the way, is very much a twin of the Earth. Um, Although it's quite a different planet, it has the same, almost the exact same mass as the Earth, and it's almost the exact same size. It's just a slightly bit smaller than the Earth. Then we have our planet, the largest of the terrestrial planets, and then Mars, which is less than half the size of the Earth. Mars, of course, is the one that we're exploring. Constantly. We've sent lots of spacecraft to Mars. There's rovers that travel around Mars. There's even a helicopter that's landed that's associated with one of the rovers, and it's still in operation as of this video. It probably will be around for a little bit longer. Anyhow, so that's the inner planets, the outer planets, starting with Jupiter. And so, by the way, between Mars and Jupiter is that's what's called the asteroid belt. All right, so Jupiter, of course, is the largest planet in the solar system. It is a gas giant. It has the most moons around it. There's more than 60, more than that actually, 60 confirmed moons around Jupiter. But by the way, all of the outer planets, all of these have rings, not just Saturn. Of course, the rings of Saturn are very apparent because you just look through a small pair of binoculars or a telescope, or even a small telescope, and you can easily see the rings of Saturn. The rings are made of ice, a little icy material, and in fact, that's why we can see them. Is they reflect a lot of light, and so they're very easy to see. And like I said, all the outer planets, these four have rings. But like, for example, Jupiter's rings, it took a spacecraft to pass by Jupiter to notice that there were rings in the 1980s is when we first detected those rings. And then, of course, Uranus has rings, and then Neptune also has a ring system, and all of these have moons. They absolutely all have moons. We'll get more into that in a little bit. Let's see. So Neptune is slightly smaller than Uranus, and technically Uranus and Neptune are actually considered ice giants, although you'll hear them referred to as gas giants as well. But they're substantially smaller than Jupiter and Saturn. All right, so let's get into the formation of the solar system. So when we look out into the galaxy and even look into other galaxies, we see these hazy areas which are composed of mostly hydrogen and helium, and the hydrogen and helium is in a gigantic cloud. And when we look through our telescopes, or when earlier, going back 400 years, we started looking at these objects in telescopes. They called them nebulae. So nebulae is the plural. Anyhow, a nebula was anything that was fuzzy looking. So we didn't, back 400 years ago, they didn't know what the heck they were looking at. Some of these objects turned out to be stellar nurseries where stars are being born. And that's indeed what happened with our sun. Our sun was born in one such stellar nursery, more than 4.5 billion years ago. These stellar nurseries, one mistake that people often make when they hear about these things is you don't have a single star being born by itself, right? I mean, they're all born at slightly different times, but you can have hundreds to thousands upon thousands of stars forming from a single nebula, depending, of course, on the size and the mass of the nebula. All right, so stars are rarely form, or if at all, in fact, form single stars. Now, when we look out, into the galaxy, most of the star systems that we see are binary systems. There's two stars orbiting each other. Our solar system, only has, of course, the sun. All right, so this is the nebula. The theory is, you have this gas cloud, and these clouds have been around, pretty much since the beginning of the universe. And it turns out, you might wonder, well, why in the heck do these things start to collapse? And in fact, if they collapse, why haven't they? If the universe has been around for 13.8 billion years, roughly, why haven't these things collapsed already under through gravitation? And it turns out it's very difficult for these things to collapse. And what happens is, as the gas molecules get closer and closer, or the hydrogen and helium molecules get closer and closer, that causes the temperature to go up, and that pushes the gas molecules away from each other. So there's there is the inward force of gravity, but gravity is an extremely weak force, and these gas clouds don't often collapse. In fact, more and more evidence shows that these things will collapse only with some external influence, right? So for example, there might be some really large star off to the relatively close to this nebula, and it undergoes like a supernova explosion, and that can trigger this gas cloud that again has been around roughly since the beginning of the universe. To the shock wave that comes from that supernova will cause this thing to begin to collapse. And when it does so, it begins to rotate, and the physics of that is very, very well understood. Once something begins to rotate, and as it gets smaller and smaller, it will speed up. The rotation will speed up, and in fact, that's called the conservation of angular momentum. So as these particles get closer and closer to the center, and in fact that's what's going to form the star. Remember, these are systems, so we're picking one small part of the grander nebula. All right, so as this small part of it begins to collapse, it speeds up, and it's just like an ice skater, for example, as she's spinning around and she pulls her arms in towards her the center, her axis of rotation, she spins faster, right? That's what's called the conservation of angular momentum. And what happens is that sphere that started out roughly spherical, it will flatten out. And that's exactly what we see in our solar system, in other solar systems as well. That there's this overall flattening out that takes place, and there's a plane where you find the planets, right? The planets exist along the plane for the most part. There are some slight exceptions. Not in our solar system. In our solar system, the planets line up very nicely along the plane of the solar system, but in other solar systems it's slightly different. We'll get to that a little bit later. All right, so as the collapsing nebula gets as the matter falls in, it begins to heat up, and that is what's called a protostar or a proto-sun for our sun. If we're talking about our sun. So this is a little more than 4.5 billion years ago, before the sun turns on. And by the way, when the sun actually becomes a star,